Yes, hello. It is now 2 o'clock, and we will start this webinar about the Stringer program. We had this webinar in Danish yesterday, and this one will be in English. But we are not many people today, but you're a few. I'll start now. What is the Stringer program? Last year we developed a new Stringer program. What is the Stringer program then? The Stringer program calculates after the Stringer panel method, and this method is explained in these two books. The first book is in Danish, written by Bjarne Christian Jensen. It's concrete construction after EN 92. Last year, Johan Blauwendraat from Holland, or the Netherlands, also wrote a book. It's called Stringer Panel Method in Structural Concrete Applied to D-Region Design. This book can be bought on Google Books, and it's a very good book about the Stringer method. This is the Strusoft dimension package, and here we have last year we have added the Stringer program, which I'll start now. This program is both in Danish and English, so we can switch between Danish here and English here. That's default. I will go in and set the grid of the grid size 300 millimeters. This webinar will both explain the calculation method, but also how to use the program. First of all, we go into some general settings where we defined the thickness of the plate we want to calculate, in this case 200 millimeters. We can also decide, is it a vertical construction, for example a wall, or is it horizontal construction that could be a plate. Here we defined the strength of the concrete, in this case 25 megapascal. We also defined the creep factor. Here for short-term loads we have defined it to 0, and for long-term loads we have defined the creep factor to 3. And in ULS, in failure, we have defined it to 0. That's normally what we do in Denmark, but you can put in your own values, of course. We can define a standard stringer width, and we can also define the reinforcement in the stringer here. That's normally reinforcement used in Denmark, but we could also use other reinforcement. That's normally used in Sweden, as far as I know. We can also select the Euro code. In this case, we have used the Danish National Annex, but the program can calculate with Norwegian, Swedish, Finnish, and British National Annex, but also clean Euro code. The Stringer method is described in the Danish National Annex, not in the other annex, but I think after 2020, the Stringer method will be general and can then be used in all countries. I don't think it's forbidden to use it, but it's not mentioned in the Eurocode, only in the Danish National Annex. We start to draw. A stringer model consists of some notes and stringers. These are notes and these are stringers. Stringers are mainly that strut and ties, basically. They cannot take moments, only normal forces. We draw the model. Oh, what happened here? Why? Okay. Here, in the notes, what can we put in the notes? We can put a support. You are, of course, welcome to ask question in the question box. Here, can we put a support here? Also here, we can put another support. What we can do with support is that we can enter a stiffness of the support, that a elastic support here. We can also put another support with a fixed displacement, for example, -2 millimeters. That will say that we no, it was with a fixed support here, fixed displacement here. In the notes, we can also put loads. First of all, we add some loads cases. For example, for on-weight permanent load, we can add one for wind. Then we can add load. For example, here we add a load of, in the X direction, we create one. No, that was in the X direction here. For example, -200 kilonewtons. That could be wind. We can also put loads on the stringer, but be aware, all the loads are moved to the nodes. So if we put in a load on this one here, all the loads are automatically moved to the nodes. We could put in 200 kilonewton per meter. Okay. We put also some load in here. And we can see the load here, permanent load and wind load. And we create some load combination. For example, in serviceability, we create a and wind. Ultimate, we create permanent load and wind. And we could also create one for accidental load. Close. Normally, this is a stringer model. We have also panels here. We will put in some panels here and with a window here and a door here. But remember, the loads from here, you see the loads on here will not come down in this one, in this panel here, it will go to the node and then down here. So if we want to make sure that some of the load go down here, we add an extra stringer here. Not here, it was here, and also here. Now we are ready to generate all the panels. We have automatic generation here. We have a window hole here. We also want a window. We want a door here. So we just delete this one and also delete this one here. Then we have a door here. We can have a stringer here or we cannot have a stringer here. That depends on the construction. We can, of course, delete this one here. We have to define the cross-section of our panels. We could use 8mm reinforcement with a distance of 200 millimeters. Close. And we just select all panels and add a cross-section to the panel. Now we're ready to calculate this model. We have 3 bottoms here to calculate with. I'll just show you the first one. Some of the panels, they have a stringer width that's more than 20% of the panel width. According to the Danish National Annex, this is not allowed. So basically, we have to change the panel width. We can do it here. We can change it to 100 millimeters. And then calculate it again. Here we see the displacement of the construction, directions here. Here are the stringer forces. Green is compression and red is tension. I think I've made a model where there's no tension. That was not the meaning, but stringer can only take normal forces. So we have one normal force in this end and another normal force in the other end. And this panel here can only take shear, that shear along the stringers. The panel, for each panel, it has to have four stringers. That's basically what the stringer panel method is about. We can also calculate the utilization of the stringers. Here is just about 1 down here. We can see it's red when it's about 1 and green if it's below 1. It's around 1 here. Also for the panels, we can calculate the utilization. It was a message. There's a message from Pierre. I will send this on YouTube later on. You can see that the utilization is above 1 here, also for some of the stringers. We can do a correction of the construction. It was this one and this one here. This one here. We will add some more reinforcement, and also for this one here. And for the panels, we will change the reinforcement. So the utilization is below 1. We will try again, make a calculation. Utilization of stringers, oh, it's just above 1 still, but the utilization of the panels, they have gone down below 1. Fine. We have also other calculation method here. We will just have a look at the calculation methods. We have a linear calculation, only shears in the panels. We have a non-linear calculation. There we have also normal forces in the panels. The non-linear calculation has to converge because we do a lot of iteration, so it can take quite a long time to do. In the linear calculation and the non-linear, we have a non-linear elastic and a non-linear plastic. In the non-linear elastic calculation, we have linear material properties. In the plastic calculation, we have that the reinforcements will yield at yield strengths. And concrete cracked at a tension strength of 0. And also concrete will cross at concrete compression strength. For the concrete in between the tension strength and the compression strength, we use the stress-strain relationship that's mentioned in the Eurocode. Here are the formulas for the utilization of the stringers. Here is the load, carrying capacity for tension and compression. We have also anchorage that we should have enough anchorage of the stringers. That's here. And the utilization, it's a max of the anchorage and the load carrying capacity. It's only for tension we have anchorage. And we have also a equation for the minimum reinforcement. For the panels, we use the equations from the Eurocode here. Remember that for linear calculation, the normal forces, they are zero. That will say this is zero and this is zero. That's the normal linear calculation, where we have zero here and zero here. And we calculate the necessary reinforcement in the x direction and the y direction. And here we have also a control of the concrete compression. And we have, of course, also the minimum reinforcement. Here we have the linear calculation. Here we have the nonlinear elastic calculation. The nonlinear elastic calculation is the big difference. That's the panel forces. Here we see that we have also normal forces here, nx and nx, x and nyy. And we can also do a plastic calculation that will take a little bit longer because it has to converge. It is calculating now. Oh, why didn't it come up with a result? What went wrong? Yes, that was a short demonstration how to calculate in the Stringer program. I think something went wrong in the plastic. We just import another model here. No. That's another model. We can, of course, do a calculation and a printout of all the results. Here we have the input data. The conclusion. Detailed results for every load combination. And we get a printout here. Here we have the construction, the note list. Oh, that was, we got the printout in Danish. We can, of course, also choose English. And print it. Show print here. The conclusion, we can see that the construction meets the requirements for minimum for utilization and minimum reinforcement. Oh, we didn't get the detailed results. Okay. Here are the Here are the results, the detailed results for every load combination. Here we can see the utilization for the stringers. No, for the stringers and for the panels. Here the formulas, and here we can see all the utilization and normal forces for the stringers and so on. It's a very good documentation for all the results. Yes. That was a short demonstration how the Stringer program is working, and also how it calculates. I hope you have enjoyed this webinar. If you have any questions and so on, you can always call me. Thank you very much for this time. This webinar will be recorded and put on our YouTube channel. Thank you very much.